All right, in this video, we're going to talk about the solar rotation lab. I'm going to share my screen. When you open up Canvas, you should see a weekly module, lab, assignments, and materials section, and you will find the solar rotation lab there. Let's go ahead and open that up. When you open that up, this is what you'll see. The purpose of this lab activity is to empirically determine the rotational period of the sun using solar images from the SOHO spacecraft. So there are some images, several images in this lab. These are the things that you'll need for the lab: the template file itself, a data file, which is an Excel file. You will have to answer the questions in the quiz inside Canvas. There will be a submit here link where you will upload your data file, and then you will need Excel to do this. There's background information here. I strongly recommend that you read that. And then the procedure begins. And you see there are two parts here in the first part of the procedure. The first part is to inspect the raw data images. And it says that we have 12 SOHO images of the sun that are at the end of this lab. And let's go inspect those right now. Here's the first image, and you'll notice a few things about it. First of all, up here in the upper left-hand corner, there is a date. This is the face of the sun. There are sunspots visible on the face of the sun. There are lines that mark off the latitude and longitude. And then there are a couple of spots that are labeled here. You can see there's sunspot A and there's sunspot C up at the top there. And if we scroll down, you can see there are other images. Here is June 23rd, the next day. And now there is a spot B also visible. So there are spots A, B, and C. As we scroll through these, you'll see the dates increases and the positions of the sunspots move. They go from left to right across the face of the sun throughout these images. Now, your job will be to determine, first of all, the positions of these spots for all of these images. So let's say this image right here, spot B is at that location there. You need to determine its longitude, and its longitude is measured by these lines here. This is 15 degrees, here is 30 degrees, then 45 and 60. Well, spot B is between 15 and 30, so let's see, if I estimate if there's 15, then there would be a 20, then there would be a 25, then there would be 30. So I'm estimating that one looks like it's about at the 25-degree mark. So for this specific day, for spot B, I would estimate it to be somewhere around 25. Now you can estimate it a little differently. Perhaps you want 26, perhaps you want 24. But somewhere in that ballpark is the correct answer. And you'll do that for all of the spots on all of these images, and you will record your answers back up here in data table 1. And you can see the first two spot locations have been written in for sunspot group A on June 22nd and June 23rd. Those two datas are already filled in. You notice they're negative. That's because they're to the left of the meridian of the face of the sun. So some of your values will be negative, and then they will turn positive as the sun rotates. Okay, so that takes care of inspecting the data. Data collection, we just talked about that. You're going to record data positions for all of the sunspots in data table 1, and then data table 2, and there's a data table 3 and 4 and 5 and 6. Those are filled in. These later data tables are filled in the analysis section. And the instructions here are pretty straightforward. I think you'll do well if you follow those instructions. But the things you're going to fill in are back up here, scrolling back up. you're going to fill in data table 2 and then 3, 4, 5, and 6. You notice here for data table 2, uh, it, this is the longitudinal rotation. How many degrees per day did sunspot group A change? And you can see from June 22nd to June 23rd, sunspot group A moved 15 degrees. And the way you got that is you subtracted the values from data table 1. Some of these you will not be able to fill in because you don't have enough data. For example, I think sunspot group B was missing in that first image, so you won't fill that in. Don't put 0 there. 0 is an actual legitimate longitudinal value. Instead, just leave it blank and fill in the ones that you have data for. After that, data table 3 here is the average longitudinal rotation. That's just a straight average of the values from the previous data table. And you can see that that's going to have units of degrees per day. So that's how many degrees each sunspot group moves on average per day. Then data table 4, there's corrected average longitudinal rotation. That has to be, your values from the previous data table 3, have to be corrected in data table 4 because of the motion of the Earth. And that is an easy correction. If you read the instructions, you'll see it's really trivial to do. Then in data table 5, the rotational period of the sun. Think about what you did for data table 4. That's the number of degrees per day. Here in data table 5, you want to know how many days does it take to go one complete rotation. In other words, if you go, I'm making up a number here, let's say that there's a 10 in that blank right there. So that would be 10 degrees per day. Well, how many days does it take to go 360 degrees? Because 360 degrees is one complete rotation. So 10 degrees per day, that's going to be 36 days to get one complete rotation of 360 degrees. Well, your numbers are not going to be 10. I just made that number up. But it's the same idea. How many days does it take to go one complete rotation? That'll involve a little bit of math. If you're confused about how to accomplish that, then it might be good to talk to other people in the virtual lounge. That's a good place to share your ideas on this. But it's not too tough, so I'll leave it up to you to figure out how to do that. Then data table 6, the average rotation, that's a straight average of the results from the previous data table. That's all covered in the analysis, and I recommend you read all of those instructions carefully so that you can complete that. And then comes the conclusion, and you have to submit your data table. Once you filled in all of your data tables, you have to submit those, and then you have to answer these questions. Let's go back to Canvas, and here, if you see the data file, if I click on that and open that up, open it with Excel. Okay, here I am sharing the Excel file that I just downloaded. When yours comes up, you may have to enable editing. But these are the data tables, and these data tables look exactly like what we saw in the lab template. And you can see across the bottom here, there are tabs, and there are several data tables. So there's data table 2, data table 3, data table 4, and you can slide over, and there's data table 5 and data table 6. So let's go back to data table 1. These are the things that you need to fill in. And all of your computations for 2, 3, 4, 5, and 6 need to also be filled in into this Excel spreadsheet. And this is what you're going to submit through the Submit Here link. Now, I had one student say they didn't know how to make the little degree sign there, and that's fine. Don't worry about it. It's not important. If you can do it, great. If you can figure out how to do it, wonderful. If you can't, it's not an important thing that you need to know how to do for this lab. There's also the quiz, and if I open up the quiz, when you take the quiz, it's going to look like this. You enter numeric values into these blanks, and those numeric values correspond to the questions that are in the lab template. So you have to look at the lab template to know what the questions are asking you. And that lab template is this right here. So these are the 1, 2, 3, 4, 5 questions, and you pull those values directly out of your data files. Now, the values that you have in your data files may not be perfect, and it's okay, but they are expected to be within a certain range. And as long as they lie within that certain range, you enter those values into the quiz, you get credit for that. The last question here is you have to do a percent error. We are told the accepted value for the sun's rotation is 27.2753 days. That's an approximate value, and your number should be relatively close to that. It's not going to be exact, but you know, if you get 25 or 30, that's close. All right, you're going to plug your value in that you compute for the sun's rotation, subtract off the accepted value, and the accepted value is this 27.2753, and then divide by the accepted value. Notice the numerator here has absolute values across it, so the top of that fraction is going to be a positive value. Multiply by 100 so that you get a percentage, and that's your percent error. So once you calculate the percent error, that's going to be the last thing that you enter into the quiz. And don't worry so much about what value you get. You know, in a perfect world, the percent error would be 0, but you're going to have some percent error. If you get a percent error larger than 100, that's pretty bad. Maybe you should think about redoing the lab because of such a large percent error, but that is still an acceptable value for you to enter in for question number 5. All right, once you've done that and you've submitted your Excel spreadsheet through the submit here link and you've answered the questions, then you're done with the solar rotation lab.